Alrighty, folks, you ready to rock and roll? Because we're not, but we're going to do it anyway. That's how awesome this is going to be. Hi, how are you? How's things? How are you enjoying the show?
Good.
Show of hands. Awesome or like 11? Awesome. 11. Up to 11? Yes. There we are, Spinal Tap fan. Right. So we didn't put who we are slides. So my name is Josh Long. I'm the developer advocate for all of the open source Spring technologies at Pivotal. And this is my esteemed colleague, the one, the only, Roy Clarkson, who will now introduce himself.
Roy Clarkson. I'm the lead for Spring for Android and also Spring Mobile projects. Yep.
Does real work.
Real work.
Yeah. So this is kind of a dense talk, so we're going to kind of move fairly quickly. Don't hesitate to raise your hands if you have questions. I expect we'll get to them eventually, and if you have a question, just ask it. We'll make sure to either address it or move on, and you'll get your answer in due time. Okay.
Right. Did any of you guys go to Ben Hale's presentations on REST? Maybe. Yes. All right. So I'll apologize. We're going to repeat some of that stuff, but it's valid and important in
Smile.
relation to what we're talking about today.
Say Spring. You guys aren't doing it very well. You're not. Try again. Spring. There we are. Okay. Okay.
All right, so REST is an architectural constraint based on HTTP 1.1. It was created and designed by Roy Fielding in his doctoral dissertation in the year 2000. It embraces HTTP, but is not standard. There are no hard and fast rules for this. It's really an architectural style. It's something that you can adopt to your application to varying degrees. You don't have to utilize all of it, and we're going to go through all of those different degrees later in some other slides. But typically, you use the headers to describe your requests and responses. And if you're truly taking advantage of REST, then you're going to use the HTTP verbs. So GET requests. You can retrieve information. Typically, these may have side effects, but that's not necessarily expected when you're retrieving information. So for example, if you retrieve an image, it may log that you retrieved that image, or it may update the last another record or something like that. But that's irrelevant to the fact that you're retrieving an image.
For the client, there should be no perceived difference between one request and another.
That's right. Deletes. So you can use the HTTP verb delete, and you can request the resource be removed, though this doesn't have to happen immediately. Meaning, if I make a request to remove an image or profile image, for example, then it might go into a job that gets processed at some later point, and so it's not necessarily going to happen right as I make that request. Posts. So typically we use posts to create a new object, and we can also use it to update. We say that we do something with a post. So we're passing an entity in the post data, and it's going to be updated or created. In contrast, a put can also be used very similarly. But the idea behind a put is that subsequent requests with the same put request do not, or excuse me, they always result in the same action taking place. So for a post, what you could have happen is that you could create a new object, and it might end up with another ID each time you make the same post request. But with a put, it should always be the same record that is created or updated within your database.
And with a post, it's fairly common to then return a HTTP 201 header, wherein you contain that signals to the client that this is accepted, but you should also check to see where the resource lives, and you'll often, as often as not, you'll send a location header back with the client, stipulating to the client where the resource will live after it's been posted. Thank you. So it's good for, one is about creating, the other one can be used to update as well as insert to a known place.
Exactly. Okay.
So that was like the ultimate and basic REST 101. I'm sure. Just by a show of hands, how many of you are using REST? Oh, you guys are awesome.
Everybody.
I
Okay.
love you guys.
Great.
REST it is the win, right? This is what we've been waiting for a long time. How many of you guys remember DCOM, Corba, SOAP? Does anybody use SOAP anymore? I mean, terrible, terrible thing. Well, it is. It really is. I mean,
you should be glad that half the room didn't raise their hand.
Yeah, I'm just, no, you're in the right place. We're going to help. And if you are using SOAP, like I said, I've got a standing offer for hugs. It's okay. It's okay. All this time, we've been looking for a way to like share services on the web. We've been looking for a way to do that. It hasn't been very easy, right? I remember 10 plus years ago, the idea that I could drag and drool an EGB component from some sort of palette and put it into my application, and I'd be able to reuse a component, a service of some sort. And of course, there was like 2 services that sprung up ever, right? So yeah, REST is much better. The problem is that there's not, as Roy mentioned, any particular standard. There's no hard and fast rules for REST. And so as a consequence, you see varying levels of compliance with REST, right? Varying levels of RESTful services. And this in of itself is a problem, right? Because there's no way to grade or judge just how RESTy this service is and how to interact with it. So a gentleman named Leonard Richardson introduced what is called the Richardson Maturity Model. This is a model by which you can grade the degree to which a RESTful service complies with so-called best RESTful practices. There are several different levels, very much like the Dante's Inferno and different levels of hell, right? So you start at level 0, the swamp of pox. This refers to using HTTP, and that's about it. It's incidental. The fact that you're using HTTP is entirely irrelevant to the fact that you're trying to communicate data over the network. It just happens to be the transport by which you're communicating awful things like SOAP payloads, right? You're just using SOAP as a way, you're using XML to describe remote method invocation, right? Or maybe if you're using document literal SOAP, but it's still not really relevant. You could do SOAP over JMS, for example, right? Have you guys done that? Because it's much faster than using HTTP. So yeah, SOAP is, you're using XML, but again, you don't have to for a level 0 kind of service. You're using HTTP, but you're not leveraging HTTP. It's just a transport. You might as well have just used some other protocol, right?
I always think about the postback model in ASP.NET. It's just this big blob of stuff that gets...
Yeah, or JSF, where everything resides in one URL, right? So level 0 is bad. SOAP isn't the worst offender. Obviously, things like XMLRPC, which are much lighter weight in nature, but still they're very much violators of RESTful principles, right? XMLRPC is a way to do remote method invocation using XML calls against a web service. A web service, one URI, okay? Level 1 is where you start to get a little bit better. Now, instead of having just one /URI or one endpoint for your web service through which all calls transit, now you have different URIs for different entities or nouns in your system, okay? So if you have articles, you might differentiate each article by a different URI. But basically, it's still very much what you had going before, where you're just, you're tunneling all this stuff through HTTP and not really taking advantage of HTTP's real innate value. Level 2 is where you start to take advantage of HTTP verbs, okay? We start to take advantage of the native characteristics of HTTP. This is where you start with Spring. If you're using Spring MVC and you do everything wrong, you still end up at level 2. I mean, it's good. It's a good place to be. Spring MVC helps you get very, very far along the path and do the right thing by default, okay? So here we're going to take advantage of things like status codes and headers. We're going to use HTTP to actually send back different types of responses based on the accept headers. For example, do content negotiation. This is a good place to be, and you're perfectly fine if you stop here, sort of. I mean, this is actually, I call this demo REST. This is REST that you could do in a demo. And, I'm not going to lie, I've done it before myself. A lot of my demos have just been level 2 kind of stuff, because that's how you teach people the basics of REST, right? It's REST 101. It works, it's fine. But I wouldn't call it production-ready REST. I wouldn't call it something I could go to a big enterprise and actually say, here, deploy that, that'll be fine. Because you're missing things. You're missing a lot of stuff. When you use level 2 type of REST services, everything works as you expect. The verbs are there. One common question we get is, okay, well, great, Mr. Smarty Pants. You've got REST. You've got all these great services. I've stood up my HTTP delete and HTTP put endpoints, and now I'm trying to use it from a browser, and not so much, right? The browser doesn't support, any browser doesn't support today, put or delete.
How many people were aware of that, by the way?
Did you guys know? Because it kind of took me by surprise. A couple of years ago, I was very sad, cried about it, and actually, I did cry about it. There was a guy at our company. He's a great guy named Arjen Poetsma, and he doesn't listen when I cry, but everybody else cried too. So he fixed it. He actually created this amazing thing called the hidden HTTP method filter, which is very much inspired by a. The web is turtles and hacks all the way down. So this is a hack, but it's a very elegant hack. It's originally came out of the Ruby on Rails community. They have a way of tunneling or routing HTTP requests into a REST service based on the presence of a request variable, request parameter. Okay, so I can make an HTTP post or HTTP GET call to a URI and say underscore method equals delete or underscore method equals put. And so Spring MVC intercepts the call, sees that yes, you are making a post, but in point of fact, you actually intend for the controller that does deletions or puts to be invoked, and it invokes the correct service for you on your behalf. So you get the best of both worlds. You get to have your HTML5 application, and you get the full complement of the HTTP verbs that you want to work with, all for the price of one very easy to use, very convenient little filter. So far, so good? Okay.
Is an interceptor the same thing, or it's only a filter?
It's a filter, but you can. It's a Spring filter, and you can set it up using that, or you can use the servlet 3 initializer mechanism, in which case it's just one programmatic thing to set up. So, okay. Now that you're at this level, there's more to detail.
So in addition to the verbs, we've also got status codes, and we're going to go through some of those right now. The 100 are informational, 200 status codes are successes, 300s are redirects, 400s are client error, and 500 are server errors. So in combination with the verbs, you can use these status codes to really create a very robust and capable communication between your client and your server. And we'll go through a couple of examples of each. And 200, everybody's aware of this one. It's OK. 201 is created. Oftentimes, you'll see this when you're doing a put or a post, for example. 202 is accepted. The server has accepted the request, but not yet complete.
So for example, if you upload a big image, the server can send back 202 saying, hey, we got the image, but you shouldn't try and request it because we're not done with processing it. So the client can disconnect and move on, but he should poll. He should check that status or wait or do whatever, some sort of protocol you establish to wait for the actual resource to be available again.
Yeah, exactly. I like this graphic. 406, not acceptable. If anybody's ever tried to wash a cat, then you'll know it's not acceptable for the cat. You've tried to wash a cat, haven't you?
I have.
Yeah.
Heard them, watched them, heard.
So 400 is a bad request. That means it's a malformed syntax, and you need to retry but changing your request. 401 is unauthorized. Oftentimes, for example, when using Spring Security, you will get a 401 unauthorized if you try to access a request without having first authenticated. 403 is forbidden. The server has understood, but it's refused the request. So that doesn't sound very nice, but nevertheless. 404, not found. The server cannot find a resource. We're all aware of this one. I've seen it many times trying to browse the web, I'm sure. 406 is the one we just showed you, the not acceptable. I think we got the wrong description there. 409 means there's a conflict, and you could use this, for example, if you were trying to update a record and there was a existing record that was in conflict. So this would be a case where you could make use of this status request or status code to indicate to your client that they need to try to modify their the user needs to modify their record or change some data to try and fix something before saving it again. Okay. Clients and services must agree on the representation media type through content negotiation. So this is what I was just describing. What you need to do between your client and your server is to agree upon and establish a contract between what the headers and the content, the headers and the status codes mean, but then also on top of that to agree upon what the client is going to accept and what the server is going to be sending. So in this case, the server can set the content type of application JSON, for example, and that's telling the client that it should understand that it's JSON, and then it can try to parse it and use it as JSON. On the flip side of that, the client could ask for JSON or it could ask for XML, and you would set the accept header on the client for that. Now, it's up to the server whether or not it can actually respond to that. A client might request something that's not available, and in that case...
What code do you get then?
406, unacceptable.
Think unhappy cat.
Right. Okay.
Spring MVC has a very pluggable mechanism for content negotiation. By default, it does the web-centric way. It uses accept headers. However, you can say, okay, well, I can specify that I want to get this resource, and I can say, okay, format equals XML, or format equals JSON, or I could set a post variable or something. You can specify different strategies for agreeing upon a different type of media type or MIME type to send back. Okay, so let's take a look at a quick demo here. This is just a level set. We're doing, again, REST 101, okay? So we're going to hurry, hurry, hurry. So I think I have enough code. Goodbye. We are cheating here because we're using Android, and it happens to work a little better these days in the IntelliJ, so we have everything running out of that. This code, by the way, if you like to follow along at home, is available on github.com/Josh Long. It's called the Spring REST stack with hyphens in between each token or word. Let's see, close all this stuff. So, okay, we have a basic REST service here, yeah? Very typical, nothing particularly fancy. I'm using, by the way, Servlet 3. So everything you see here is all Java. There's no, the only XML we have in the entire application are the Maven build files, which is avoidable if I were to switch to Gradle, or the Android XML binaries, the resources there. Otherwise, it's all just Java. So this is a Servlet 3 web.xml, if you will, this class here. And this does double duty. It's actually a Spring provided class. It has template methods in which you can specify the global context beans in configuration, as well as the dispatcher local configuration. So here I'm saying, I want my services to be available globally, kind of like you would in web.xml using context loader listener. And then my web dispatcher servlet specific configuration, I want to live inside of my web MVC configuration class. I can register filters that I need, for example, hidden HTTP filters and the multi-part MIME filter that we need for that. And I can even do things like after the dispatcher servlet has been registered, I can get a callback. And in that callback, I can do things like specify where the Servlet 3 specific file upload support should store the photos that are in transit between upload. Yes?
Can you make that font a little bit bigger?
I think I can, maybe. See, this is why I'm leery of IntelliJ, because I don't know how to change the font. Oh, Santa Maria, what are you doing? No. Default, save as, Spring 1. Okay. Make this. Yeah, maybe, sort of. Huh? Yeah, yeah.
What is the name of the project?
The Spring REST stack with hyphens in between. At Josh Long, one word, GitHub. Can you guys see that, maybe? Yeah, regretfully, very, very small screen. And we have so much to give, so it's very sad. Okay.
It didn't update it. Can you just try zooming in on that?
Wait, I didn't save it? Thank you. Voila. Yeah, how's that? Huh? Might be a little too much, huh? Don't worry, folks. What we lose now we'll make up in awesome later. So apply, okay. Yeah? Okay. Okay, this is just a dispatcher servlet. What this does, this class, it sets up, this is a Java-centric web.xml, and it's also roughly equivalent to what you would have specified in your servlet config.xml for Spring, okay? So it's double duty. I get rid of 2 configuration files for the price of 1 class. The only thing I have to do here is I wanted to specify WebMVC. I wanted to set up Spring MVC as well. These days, setting up Spring MVC is a matter of one little annotation on top of a configuration class. In point of fact, if I didn't want to use the Servlet 3 support, and if I didn't want to specifically rely on that, I could even omit this particular code, right? I don't even need that bean. All I want to do, because remember, by default, when you have the @enable WebMVC annotation on the class on your configuration, it looks in the class path and says, okay, do you have Commons file upload? If you do, then we'll support that. If you have Servlet 3 environment, which supports file uploads natively, then we'll use that. If you have both, then you introduce an ambiguity and it gets upset. That's why I'm pinning it down and I'm saying go ahead and always prefer standard servlet multi-part resolution. And if you aren't in a Servlet 3 environment, it will complain. Okay, so that's a very basic configuration class. I'll show you what we've changed as we progress through the demos, but basically everything looks basically like this. I've got a controller here. This is a regular Spring MVC RESTful controller. I'm using public static final constant strings to keep my URIs in one place. That way I don't have to repeat them everywhere I'm configuring URIs. But what I'm saying here is I've got a controller and I want all requests to /users to be routed to this controller, and then specific controller methods will handle specific sub-URIs. So for example, users /5, which is the ID of a user, will get routed to one of these methods that has the same URL users user, okay? That little, you can't even see it, but it's a little curly bracket user curly bracket. That's a path variable that gets extracted at runtime and made available as an argument in the controller method. So here I'm saying user is 5, then the value will be 5 at runtime, and I can just pass through onto my service and actually delete the record. Again, nothing particularly special. We're just sort of, it's just basic REST 101, okay? Let's start that bad boy up. Here we go. Oh. There are, of course, no bugs in this code, so I will delete all those breakpoints because we never make bugs. Do we? Wow. That is awful. Okay, good. Gonna close all this stuff down. Close that guy. Okay, so the first one is just the RESTful service. This is level 2, okay? This is where you start. If you've got this far, you've done a great job of doing what you should be doing on day 1. But don't go to the boss and say you're done yet. Don't close that ticket because we can do much, much, much better. Okay. So, if, as you might expect, if I go to users 5, I can get my information. This is being drawn dynamically out of a database. I've got an H2 database running in memory. I can actually see that database in play here. Whoopsies. Log in. Go to my user accounts. Okay, so this is where it's all coming from, right? So I go to localhost 80 users 5, and you get the JSON representation of a user object. This is a very, very basic, no fuss, no muss CRM domain model, demo model, right? Just a CRM. One user has a 1 to n customer records he can manage, or she can manage. I've got information about which type of profile photo I have, whether the photo's been updated or imported, what time I signed up, etc. If I navigate down to the user 5 customers URI, I can actually see a JSON representation of the collection of customer records under that user's account, right? So this is just a JSON array. If I were to go to users 5 photo, I get the profile photo for my account. That's the Spring dog. That's a Spring Source beanbag from Spring 1 last year. I may have a different photo next year based on all those beautiful, beautiful beanbags upstairs. So yeah, that works, but there's some very, very, very drastic problems with this. First of all, you notice that I have to remember all the URIs, and while I remember the URIs as I helped write the code, I can't expect the users to figure it out, and I'm certainly not going to write documentation. I'm a developer, damn it. So let them figure it out, right? There's got to be an easier way. The other problem is it's not secure. I was just able to kind of go in there and just mess with the data. So let's address the first problem. Level 3, as described by the Richardson maturity model, introduces hypermedia, okay? Or HATEOAS, I don't know. It's the acronym that remains unpronounceable. It's hypertext as the engine of application state. The idea is that you provide metadata in every response that the client can glom onto to better understand the relationships of the data that's being displayed. So if I want to look at the customer records underneath a particular user, that metadata, there should be some sort of directory or some sort of table where I can actually see, oh, if I navigate to this URI, I can get the customer data. Or if I want to see the profile photo, I can navigate to this URI.
So the general idea is that it's self-describing and discoverable, right?
Right. You can, of course, still hit the direct URIs, but in theory, you shouldn't need to, right? The contract between you, the service provider, and the client is now the name of the URI, not the URI itself. It's the name in the phone book, not the phone number, right? You have a little bit of double dispatch there. You have a little bit of dereferencing. But as a result, you promote more flexible, more long-lived, uniform APIs, okay? This is promoting long-lived HTTP APIs. We're talking about something that should stand the test of time over decades, not just until somebody breaks the API like Facebook does every 2 months, okay?
So let's describe a real-world example then. Say, for example, I've got an Android client, and I want to access an API. Maybe I've hard-coded a lot of URLs into that client, and then you, as the service provider,
if I want to develop it, I should be able to test and navigate. For performance, you might not want to always navigate through those links, you know.
Right.
But for discoverability, for development, it's nice to be able to bang around on the API and see where I'm supposed to go and see what is relative to what, etc. The way I described in very abstract terms this idea that you send back metadata. In concrete terms, that means we send back links, right? You guys, how many of you have had the sort of dubious pleasure of working with HTML? Raise your hands. Again, no judging. We're all friends here. HTML has this link construct. It's a very useful construct. It says to the browser, the client in this case, that I have a payload, this HTML document, and that I want you to make available resources that are also going to need to be included. And so you signal to the client that these resources should be loaded. In this case, you do it for CSS. So it says link rel equals the CSS, and then you have a pointer to the CSS document. But that link construct is a standard. It's actually something very generic, and it doesn't need to be represented in XML. You can use JSON, or I don't know, whatever you want. But the point is you can send that same data, that same structure back any way you like. OK, so that's, let's take a look at a hypermedia-aware REST API as implemented using something called Spring HATEOAS. OK? I've got a different version, same code, same basic API, same domain model, same everything. I've just upgraded it to use HATEOAS. So I'm going to go ahead and sorry, question?
Is HATEOAS emerging from the dissertation, or is that a body that came up?
Hypermedia, HATEOAS, is not directly related to Roy Fielding's work in his doctoral dissertation. It's kind of a pattern that's grown up in the last several years. It is, I think, best described by a book called Rest in Practice by, boy, oh boy, what's that guy's name? He's the, Jim Weber. Jim Weber, the guy from, it's an O'Reilly book. He's the Neo4j chief data scientist or whatever. He's a good guy. He wrote a book called Rest in Practice, in which he describes this very technology, this very approach of using hypermedia. One common, the canonical, actually, use case for hypermedia is the Starbucks cafe example. Have you guys, how many of you have, you know, I've got a background in enterprise integration, and in that world there's a book called Patterns of Enterprise Application Integration by Gregor Hope and Bobby Wolf. It's a big, giant tome about the size of your abdomen. And it literally invented the jargon, the lingua of integration, sorry. And then he wrote this great post called Starbucks is not transactional or synchronous or something like that, right? The idea is you go to a cafe, you make a drink, you send a message, which is the cup with some data on it, to the barista who's going to make the drink. But you don't wait for him to do it. You proceed to tally up the toll and take the money and all that stuff. So it's a very asynchronous message-oriented system. This is true for web applications too, and REST. This is messages being sent back and forth between services, okay? And just like an enterprise message in JMS or RabbitMQ, every message has a payload and headers. In this case, HATEOAS encodes those headers as links, that metadata as links, okay? And so if you saw Oliver Gehrke, he's got an amazing talk here that's already been passed, but you'll see it online if you haven't already, dissecting something called Spring RESTbucks, which implements this pattern, this Starbucks cafe example that was in the REST in Practice book, which in turn was based on the enterprise integration pattern from the book from 10 years ago. So we are going to use HATEOAS for our example. So I can go to users now and get nothing. Go to my specific user though, and you can see I've actually got now the same payload as before. I've got my ID, I've got my first name, I've got profile information, whether I'm enabled or not. But I've also got this other attribute, a links attribute, right? And the links is just a collection of links, right? Each link has a rel, says this is why this link is important. This is the self URI. And this URI points to this. It's localhost 8080/users/5. I have another link for customer data. So if I were to receive this payload inside of jQuery or whatever, I can just navigate down to the links collection, find the customers one, and then look at the href and follow that link to get to the customer data, right? Same thing for the photo. I want to access my photo. So the link for the photo lives here, right? Just as before. So that works. I mean, that's a very convenient way to work with the system, okay? To write that kind of code, though, you need to change your API just a wee bit. So I've upgraded my configuration. I've added this very important enable hypermedia support annotation. This turns on Spring HATEOAS, assuming you have the libraries on the class path, of course. And then everything else, I think, remains the same for the moment. So we have a controller. I have two controllers, actually, but the first one is the one we saw before. We'll look at that now. And the idea is for every request that comes in, instead of just sending back a response body with the domain type, what I'm actually sending back now is an HTTP entity, which contains a payload of type resource, which is a HATEOAS envelope, if you will. And then that, in turn, has a payload of type user, my original domain entity. So I've managed to drop the @response body annotation, but now I've got this slightly more convoluted triple generic type thing going on, okay? HTTP entity is a Spring MVC construct. It's been around since 3.1.2 or something like that. It's a fairly awesome thing to introduce in a point release. And the idea is that you can, in a REST response entity, provide both the payload as well as things like status headers and as well as things like the status and headers that you want to send back to the client, okay? This can get a little boring. I mean, I don't want to create a new resource for a user every time I have a user type that has to be sent back to the client. So you codify the recipe for doing so in something called a resource assembler. Here I've got a user resource assembler, which implements Spring HATEOAS' resource assembler contract. It's basically a map from user to resource of user, okay? And here I say, okay, get my user from the service, again, just as before, and then build up the link collection. Set up the link for the user, the customers, and the profile. I'm doing something pretty epic and magical here. I'm using Spring HATEOAS' innate ability to use proxies to get the metadata about those URIs dynamically without actually hard coding those URIs. So what I want is to add a link to my collection of links for the customer's photo and all that stuff, but I don't want to have to repeat the information that's in the request mapping annotations on each controller method. That string is there for a reason. I don't want to have to have it in two places. So thankfully, with this link to DSL, the fluid DSL, I can then create a method on proxy, which gives me a proxy of my controller, and then I can invoke methods on it. These methods do nothing. They're empty. This is just a proxy that does nothing. It doesn't actually invoke the method on the original controller. But what it does is it extracts the request mapping URI information. So the URI that I want to actually put in the collection of links, it extracts it by calling the method on the controller, and then it gives it back to me. If you've used Spring MVC before, you know that Spring MVC controller methods can contain lots of different types of arguments. You can make them all null, except for the ones that contribute to the URI construction. So if I have a Spring MVC controller method, and the controller method has a path variable in it, well, that path variable is part of the identity of the URI. So that actually has to be the right value, right? You can't Spring MVC can't be expected to create a URI for users 5 if you don't actually tell it 5. You need to pass in 5. So that's what we're doing here. We're saying load the user and then pass in 5 and give it a rel of type self. There's a shortcut there. Load the customers collection and give it a rel of customers, right? Load the user profile photo and give it a rel of photo rel. Once I've done that, I return it back, and then in my controller, I just return it back to the client just as I would everything else. And all of this still works just as we had before, except I agree we've got a little bit more code. But that's all done in the interest of better metadata, right? I have one other controller here. This is a profile photo controller. This one does the job of displaying and or updating my profile photo. So here I can say, when somebody makes an HTTP request of this resource, I want them to post a new profile photo to the URI, user's profile, users 5 photo, whatever, or users 6 photo. It invokes this controller, passes the user ID, and I tell Spring MVC that I want you to give me a multi-part file object that contains the byte array that was submitted in the request. Okay? And then here too, again, using sound good RESTful practices, I'm sending back a header in the response for the binary image with the link to that URI, right? Remember, it's good RESTful practice when you upload something or when you change something, when you post or put something, to send back to the client the URI where that resource can be uploaded or retrieved later on. Okay, that's the location header. But you don't want to do that for binary data, guys. That's craziness. No. Imagine if you uploaded a, oh, and it's also good practice to send back the entity itself. So if you uploaded a YouTube video, the right thing, the technically right thing to do, is to then have YouTube stream the video right back at you once it's done. Well, you don't want that. You don't want to upload a 20 gig video and then have it be streamed right back to you. So what I'm doing here is I'm setting up a header called link, which then has the URI where that photo can be retrieved without actually sending back the video. Okay? Questions on that so far? Maybe? A little bit? I see faces. Yeah, hi.
Link instead of location.
Mm-hmm. Good question. Oh, that's right. Yeah, links. That's actually a standard. Yeah, that's right. And I'm doing the location as well. Yeah?
It seems like this is sort of, I don't know, mechanistic boilerplate code. Could this be automated?
Don't you worry. You are in the right talk, my friend. But we are going to move on. So, that guy, I did not pay that guy to segue for us, but he did a good job. Oh, by the by, the other thing is, if you're on a Mac, we have an amazing little thing you can do. You just do brew install rest shell, okay? I'm not going to do it as I've already got it running or installed. And then with the rest shell, I can now dynamically interrogate these services. I can say follow users, follow 5 get, and there's my data coming back. I can also just say discover, and I get a nice pretty printed table of those links, so I can see where I'm supposed to go. This is where HATEOAS and Hypermedia comes into its own. I can, in the discovery and development phase, interact with my resources and really get a good feel for what navigations and relationships are available. I won't go too much into that as we're short on time already. Okay. So, segueing further, I agree. Like, most of that code was just complete waste of my time. There's no reason for me to have written most of that, particularly as all I'm doing is taking in data coming from a request, unmarshalling it into the web tier as a controller, and then more often than not, it just gets forwarded straight onto a service, which in turn just forwards it onto a Spring Data repository that I've created. A lot of ceremony for something that should just be like, straight to the database, right? So there is a way to fix that. Spring Data, how many of you have used Spring Data? Oh, guys, that killed me here, deep in my heart, and kind of over, elsewhere. It just makes me sad. Don't do that. You should use Spring Data. The idea is that most things you want to do, if you think about it, are pretty boilerplate, right? If you think about operations, working with databases and so on, think about a repository object. You have a repository method for, find by username and by first name and last name, okay? Close your eyes, squint, just imagine for half a second, what is that code going to do? I'll bet you dollars to donuts it's probably going to say select all from users where username equals question mark, and then you're going to pass in the parameter. And it's just stupid code. You guys have better things to do. You have families, people, pets, who cares? Anything else to do besides writing that stupid code. Same thing for Mongo, same thing for Gemfire, Neo4j, same thing for Elasticsearch. It's all boilerplate. It's just stupid code, guys. I haven't seen a waste of time like that since EJB, you know? So don't write it. No, I'm not kidding. Don't write it. You don't need to. It's, if you can imagine what it looks like without even thinking about it, there's obviously no creativity to it. There's no innate value in it. Let the machine do it. And indeed, we will. Okay? So Spring Data Repositories give you that ability. You provide an interface, as we've done here, and you define interface methods, like user find by username or whatever. And by convention, Spring Data will automatically synthesize those methods for you. It'll create a implementation at runtime of the user repository interface that does basically select all from user where username equals param username, okay? And to sweeten the deal, it actually has a base interface called paging and sorting repository that provides just a whole slew of methods that support things like paging, finding by ID, finding all by ID, deleting, updating, etc. So you get all that just for free, just for showing up with an interface. Now, taking things a step further, Spring Data REST, building on top of Spring Data's core concept of a repository, introduces this very nice little annotation called @REST-resource. And this transparently takes your repository and exposes it as REST. So suddenly, all that stupid, insulting, mind-bogglingly boring code is irrelevant and redundant. The only thing I need to worry about now is my profile photo, right? That photo, I'm uploading and downloading bytes for an image that I'm loading from a file system. There's no Spring Data repository that knows about how to read photos from my file system, so I wrote that controller by myself. But everything else, it's already done for me. So let's take a look at a version of that code without that API, without that extra, you know, insulting code. I would like to close this, please. Thank you. HATEOAS data. Questions on this while we're moving right along and I'm twisting in the wind as this thing loads? Comments, feedback, ideas, thoughts, hugs? Nothing? You guys.
Can you say again what the root thing you had was? You typed really fast. It's hard to catch.
I'm sorry, which part?
The root part that you had.
Root?
Where you were showing how to act shell.
Oh, REST shell. REST
yeah,
shell.
REST
I'm so
shell.
sorry. Yeah, it's called the REST shell. It's just John Brisbane is here at the show. You give him a hug. He wrote that. It's a lot of that is his. It's a great little tool for working with RESTful services. Okay.
So it was actually born from Rue, and
Yeah.
it's a project called Spring Shell, and the REST shell took that and is built on top of that as well.
Right. I shouldn't say it's all John Brisbane. He took the Rue team built the shell. Then Mark Pollock extracted it out into a separate project called the Spring Shell, and then John Brisbane wrote the REST shell in particular. Okay, so now I'm running the HATEOAS data module, not just the HATEOAS one or whatever. You'll notice that I've removed the profile, the actual controller, the user controller. I don't have that anymore. Okay, all I have now is my user profile photo controller, and this does everything as before. You know, there is one intrinsically problematic thing to mention. If you get rid of the controller, then you can't very well create a proxy that has the information with the request mapping and all that. You can't invoke methods on classes that don't exist. This is a problem. So you have to find some other hopefully conventional, hopefully repeatable way of identifying resources without actually having the code, you know, without actually having a class. So Spring Data REST provides a pattern. So instead of using a resource assembler, I use something called a links object. And the idea is it just looks like this. I create a class, I inject a reference to something called the entity links helper, and then I use that to, based on convention, dynamically build up user and customer URIs. You know, so for the type user, give me a users/5, and then mark it self. For the type user, give me users/5/customers, and then mark it as a rel with customers. Okay, so same kind of thing as before. You keep that boilerplate code in one place, and then just reuse as you like. And then you get a lot for this out of the box, guys. I mean, look, I loaded the application up, and already I've gotten something more than I had before. I have two different, you know, I have a collection, and then inside of which I have that links element that tells me where I can go from the root. So now my client doesn't, in theory, need to know the URI of anything. They just need to know localhost 8080. That's it. They can dynamically, you know, drill down based on discovering what you're discovering as they go, right? So here I can say, you know, customers, and that gives me everything, right? I get the whole thing, the whole enchilada. I can go to up here, users, gives me everything. I didn't have code for this before. I didn't have to write this. It just comes for free by benefit of the fact that I'm building on Spring Data. Of course, my user 5 is still there. It's automatically pre-printed just as before. And it's automatically provided links for my relationships. My customers is there, my photo is there, everything is there. Okay, so we're already ahead. It gets better though. Julian fries and all that. So I can go to users, back here again, and I kind of glommed over this last time. It actually even created a search endpoint. Now this isn't very RESTful. I'm not going to tell you it is, but it is very convenient. Imagine you have a screen where you want to drill down and report on data, and you want to have a way of dynamically displaying that stuff. It's nice to have, maybe for your own benefit, maybe you don't publish that to the client. It's nice to have this little endpoint here. So I can go to users, search, and remember those query methods that I have in my user repository? The one we saw on the slide as well? User repository. That's my actual Spring Data interface, and I've got two methods, one called find by username, one called find users by first name or last name or username. I can now dynamically call these query methods. Okay, so I'm going to go ahead and do this one. Username equals long. Voila. So that's pretty convenient. You know, you get a lot of power out of that. You can create as many finder methods as you like, but the point is it's direct to web. Does that answer your question? It's like I paid him or something. Okay. Now then, guys. Okay, let me see. Yeah, sir.
Your ID probably is linked to
The entity.
number 5 or something. So what happens when you delete it? Somebody marks it.
What do you expect to happen? It's not there. It's 404.
And that's okay.
Sure. I mean, URIs are supposed to be long-lived, but if you got to delete something, sometimes haters got to delete. You know, it's the way it is. Yeah, that's fine. And you should do the right thing. Send back a 404 or whatever. You know. And by the way, Spring Data REST automatically supports deletion, put, post, so you can actually contribute new things to the user's collection. You can update them by putting to users 4/5, etc., etc., etc. So, say that again?
Like, let's say this particular user does not have the right to delete.
Oh.
Do you update the list names?
I didn't pay him either. We'll get to that in a minute. Just bear with me. Yes, sir.
One of the issues I have with this is you have to modify all your return types to be HTTP and DD and all that stuff.
But I got rid of that class, so I didn't have to do that.
Yeah, he was illustrating the
Just-
manual way to do it and then how to
Yeah.
convert that over to
So I had user controller with @response body and the domain type, and then I did HATEOAS with HTTP entity of resource of user, and that was a lot of boilerplate code. And this gentleman in the front, rightly so, complained that while it does provide hypermedia and it is intrinsically more navigable, it's kind of a lot of code. And then we used Spring Data REST to just make that entire class redundant. I deleted it. So the only thing we had left is the profile controller for the photos, right? The uploading and downloading of photos, the byte stream. Now, security. This guy on the right here, who I also did not pay, asked about security, and I want to address that without falling down. REST security is a difficult problem to tackle. It's not like the web where you can just use HTTP Basic. HTTP Basic, as the XML of the creator of XML, Tim Bray, a gentleman who works at Google, has said many times, HTTP Basic auth doesn't scale. It's not web scale, right? It doesn't work. So while you can use Basic just fine with REST, it isn't actually a very good way to do it. If you're going to do security, though, you should be as progressive as you can. HTTP Basic is a good start. At least you have a challenge, some sort of challenge. You should do digest if you have the extra processing power and you want that. And TLS, of course, is very important. If you can do SSL or HTTPS, basically, that's a great thing. So you get encryption and you get a basic challenge. But again, this all doesn't really scale. The problem is that you can't trust clients today to keep a secret. They're just so darn gossipy. So for example, if I were to view source on an HTML5 page, I can't have a JavaScript code, JavaScript client that connects to a service sending a password in the clear. It just won't work. So the way to do this is to kind of circumvent the client and make the onus of security on the user, put the onus of security on the user. One way to do this is OAuth. How many of you guys have had the very, very dubious pleasure of using Facebook? Have you guys used it? It's out there. It's getting big. This is going to be big one day. You guys watch. I am telling you. They have this amazing thing called, like a couple years ago, there's this virus going around called Farmville. And the idea is you could go to this thing. What? You guys have used it, right? It's just awful. Terrible. Terrible. You can go to Farmville and say, listen, Farmville, I hear that you're very good at mercilessly and endlessly spamming my friends, family, and loved ones, and I would like to take advantage of your services. I would like to use your spamming services in my account, please. So you go to Farmville and you say, hey, can I install this spamming of my friends and family and loved ones mercilessly plugin, please? And it says, yeah, sure, but you need to give us permission. So then it redirects you back to Facebook, whereupon Facebook prompts you to log in if you're not already logged in. And then it says, Farmville would like to spam your friends, loved ones, and family mercilessly and endlessly. Do you approve of that? And you have to explicitly say yes. So if anybody says that you're not responsible for what Farmville does, they're lying. That's bullshit. I mean, you signed that contract. So yeah, don't do that. But the point is, that's the three-legged dance that is OAuth, okay? What you're doing is you're saying, I want to install something. I want to use a service as a service provider. I want to get permission from the client. That's all I'm trying to do, after all, is to establish the fact to the service provider that the user trusts this client to do what it's doing. So Farmville, you've given Farmville permission to do what it needs to do and interact with your data on Facebook's REST API. And the way it does that, ultimately, is that once you've done this, once you've gone through that flow, it redirects back to Farmville, gives Farmville something called an access token, and then this access token is to be transmitted by every client going forward. And the access token, that you can keep cached somewhere, right? That you can send. And by the way, you don't keep that hard-coded, right? You reobtain that. So if you have a single-page app, what you'll do is you'll establish the connection and keep that in the variable, in memory, in the page. Yeah?
Could you explain what you meant when you said specifically basic auth doesn't scale? When I look at OAuth 2 and setting a token, it's a bare header instead of a
well, so OAuth is very nice in that it decouples the permissions from the user. So if I send HTTP basic, imagine if Farmville asked you for your username and password from Facebook.com. What if something goes wrong? What if you did that for Farmville, which is already bad enough? And then what if you did something that people don't trust? I mean, I don't know why people trust Farmville, but what if you did it with something that they don't trust and it did something malicious with your account, like deleted your password or changed everything and spammed all your friends, family, and loved ones endlessly? You want to have the right and the ability to revoke that client while keeping your authorizations with these other clients working. Well, if they all have your password, once you change the password in your Facebook account, all these clients that are providing services for you fail to work, right? So that's what I mean. Intrinsically, it's not going to scale, right?
It's decoupling your username and password, your credentials, from an authorization token, which is all you really need to access these third-party websites or services.
OAuth, bringing spam to your friends.
What you don't want to have to do is change your password on 100 different places. You want to be able to just disconnect from one single service or one single provider.
And as that gentleman asked about earlier, OAuth has a permission model, whereas HTTP Basic is either all or nothing. You've either given me permission to log in as you, or you haven't. With OAuth, I can say, this guy has permission to, this client has permission to post to my wall and to spam my friends, family, and loved ones endlessly. But it does not have permission to read my profile data or my username or whatever. You can granularly give or authorize certain permissions to the client. Question, sir?
Does that really work for B2C instead of B2B? Because for business to business, certificates get exchanged and that sort of thing.
This is about the open web. OAuth is very much an open web kind of technology. B2B, you can still use SAML and things like that, right? I mean, that's going to be more useful, but you're not going to do SAML from a web page. I wouldn't even do SAML from an Android device or an iOS device. It's too. You've got a client there, and it's on the user's phone, and you can't. You could probably get away with sneaking in a security certificate in a native application somewhere, but again, that's not something you want to have in a. You don't want to try and make that work on side of a HTML5 app, right?
So the ability to disconnect a single device or a single client is still valuable even in the B2B area.
Oh, sure. I mean, SAML has a combination for that as well. Yep. What we're going to look at is something called Spring Security OAuth. There is, of course, a very nice Spring Security SAML integration. So take heart. If you want both, you can. And indeed, you can use Spring Security for just basic auth, as we have for the last 10+ years.
So, and even further on that, Facebook also has a expiration on their authorization token. So if you don't log in for a certain period of time, it'll actually cause you to have to reauthorize or re-OAuth again.
Now then. Okay, folks, so the first things first, we're going to launch the OAuth module. This is again, we're progressively enhancing the same code, okay? So this is the same domain, same everything. The OAuth module, hello, hello, go away. Do you need a hug, IntelliJ? Destroy Superman. Let's see.
So how many of you guys are using Spring Security or Spring Security OAuth? Yeah,
Squeak.
awesome.
It is really popular.
Have you tried using the new Java-based config with that? How do you like it? Good? Thumbs up? Getting there?
So same code as before. I've got my configuration class. Because I'm actually serving up JSP pages now to actually prompt the user to sign in and so on, I've got a view resolver here. And I've enabled the default servlet. This is standard, just basic Spring MVC. More interestingly and more saliently, I've also got a security configuration class. This takes advantage of the aforementioned Spring Security Java configuration style that Rob Winch, who also deserves a hug. He's here, guys. I'm not kidding. That man is, there's no proof he sleeps. None. Nobody's established it. The idea is you have
I'm not sure he sleeps either, by the way.
Yeah. There's a web security configurer adapter, and I have callback methods just as before. It's just like doing the using the Spring Security XML domain, DSL, right? So I'm saying, okay, ignore all requests going to my H2 embedded database because it has its own username and password prompt, and it's just a demo after all. I want that to be wide open. But other than that, what I'm doing is I'm saying, okay, let the database go through, let the fave icon go through, but any request going to users, block it unless they're challenged for authentication. And then to do that, they should be redirected to signin.html. Upon successful sign-in, they should be redirected to welcome. The login page should transmit in the payload of the post request a username and password request parameter. By default, since time immemorial, that value has been j_username, j_password from original days. I'm just tailoring it here. And then also, if somebody makes a request of sign out, you can go ahead and just destroy the session for you. So all this stuff you get for free with Spring Security, all this machinery.
Yeah, and I don't know if you guys are familiar with the XML configuration, but to me, reading that builder pattern implementation is just very readable and very much more accessible than the previous XML.
Not to mention you can step through it, which is huge. The other thing I have neglected to mention, I have a user detail service implementation. This is the beating heart of Spring Security. All things on top of Spring Security build on this. This interface answers one question. It says, give me information about this user given a username. Doesn't matter who answers that question. You have different implementations as the use case demands. So for example, you can talk to LDAP or Active Directory or SiteMinder or CAS or PAM or whatever, or OAuth, or your own database, okay? I have built an implementation of this that works, whoops, wrong one. I have built an implementation this class to adapt my existing user service, because I've already got a JPA object that answers questions about my user model, right? I've got a CRM service in typical Spring style that talks to JPA and all that stuff. So I'm just going to adapt that service into the user detail service contract that Spring Security needs to be able to do its work. And so it's very simple. I just, load user by username, I call the service, find my user by username, and then I wrap that user in a CRM user details object, which in turn implements Spring Security's user details interface. And this is where I can actually tell the client or tell Spring Security about permissions. So the way you do that is you have to answer the question, what authorities does this thing have? In my case, all users have the same authorities. I've just hard-coded the strings. But you, in your example, could resolve those authorities by looking at a database. You could dynamically say, this guy has 2 permissions, this guy has 3, or whatever. So yeah, cool. And everything else. I can answer questions like, what's the password, what username, is account expired, et cetera, et cetera, et cetera. Okay? Once all that's in place, oh, whoops, I've neglected one last thing. In my security configuration, I've also got the OAuth stuff, right? So I've got a OAuth 2 server configurator adapter as well. So I've got 2 pieces of OAuth here. I need HTML. I need requests made against the HTTP service for HTML pages to be responded to with a login challenge and an HTML page. And then I need OAuth requests to also do the right thing, right? So here I'm saying, if somebody makes a request identifying himself or herself or whatever, identifying the client as the Android CRM client, then that client needs to send me a secret password, and I will support, as an OAuth service, different types of flows for authorizing that client, right? Different flows for different folks, you know, to paraphrase that great little song. And I can also say that this client has certain permissions. These strings correspond to the granted authorities that we just looked at in the user detail service, okay? So I can say, Android CRM will get these two scopes. These scopes are an OAuth way of describing permissions. So in the OAuth world, it might be Facebook post a wall, or Facebook read profile, or Twitter send a tweet, or Twitter read my tweets, or whatever, you know? These strings are arbitrary, and you can provide them as you like. And again, you should do it as granularity affords you, right? So for an HTML5 page who can't keep a secret, of course I shouldn't configure a secret, because it can't do it anyway. There's no way to keep a secret in the HTML5 JavaScript code, right? So don't bother asking. And accordingly, maybe you shouldn't give it write access. Maybe the HTML5 code should just be able to read and maybe make a change to some resources or whatever. For iOS, I want a different flow.
It's actually worth noting that this is OAuth 2
Yeah.
being configured here.
Right. We have support for OAuth 2 here, yeah. Questions?
Mm-hmm.
Good, because we have to hurry.
So I do want to highlight this,
Yeah,
though.
highlight.
The fact that we have both an Android and an iOS client configured here, and they're configured independently of each other to a degree. But that means that you can then deauthorize one or both of them independently of each other, because they report each other as Android CRM or iOS CRM.
Right, so this is identifying the client, not the user. Okay, this is important too. So what we're saying is a user may install the TweetDeck application for Twitter. And that client identifies itself to Twitter's API as TweetDeck. We're hard coding this here in Java code using the in-memory client details service configure. You could just as easily put this all in a database, so it's dynamic. So for example, if I wanted to have, like Facebook or Twitter, I can go to their web application and build my own Facebook client that works with the data there. I register myself as an application developer, and I get back a client ID and a client secret. So the client ID in this case, hard-coded, is Android CRM, and then my secret is whatever. So if you wanted to store all that in a database and let other people dynamically register to be a client for your service, you could do that, right? I'm just keeping it in code for a brevity.
For anybody who's worked with OAuth, though, you'll know how complicated and tedious and frustrating and annoying it is. And the fact that Spring Security really obfuscates all that from you and just makes the configuration so easy is just, it's a real blessing.
Seriously. Okay, so with that in place, now we're going to try this two different ways, okay? I can go to the website here. So if I go to like that, I get redirected. So I hit / it redirects me to log in. This is HTTP basic kind of stuff. It's not actually basic, but it's a form-based authentication. And then I can interrogate the resource on the website as well. Much more importantly, I can also use, I can also build an OAuth client, okay? We have an amazing project that we call Spring Social. Have you guys had the pleasure of playing with that? It's epic. Seriously, if you want to know what has enabled me to take more time off and actually sleep more in the thing that has helped me the most in the last couple of years, Spring Social. And the reason is because right now, we live in a world of SOA. It's taken a long time, but we are out there. There's so many great APIs out there, right? And they're all OAuth. I mean, 99% of them. And so not having to write all that code is very, very valuable. Spring Social provides a core authentication and authorization mechanism as a client for OAuth-based services. On top of which, we've layered lots of great projects that have Java-typed bindings for consuming those OAuth services. So we have Spring Social GitHub, Spring Social Facebook, Spring Social Twitter. These are all provided by SpringSource, right? And we have projects in our GitHub Spring Projects repository. And these we try and keep working as much as we can. We tend to follow the API. If Facebook, as they are wont to do, announces that they're going to break all the clients and change one little character in their API because they feel like it, chances are we'll probably be on top of it. We'll have a fix in our client, within a couple days' time, right? That's the nice thing about having this. But it is just an open source project, and it provides a core API, a core authentication library for using OAuth, independent of actually talking to these specific services. So Spring Social Facebook, for example, reuses the core. It handles what I call the OAuth dance, what Spring Social lead Craig Walls calls the OAuth dance. It handles all that for you, and then it gives you back an instance of Spring's REST template. Have you guys used that? REST template does for HTTP calls what JDBC template does for JDBC invocation. It makes it down to one line for common scenarios. And it gives you a REST template that's already pre-configured with an interceptor that knows how to do the OAuth dance. It knows how to transmit the bearer authentication header on all requests for you. It knows how to redirect back and forth and handle the dispatch and all that stuff. So you get all that stuff handled for you, and then you're free to build the client that actually invokes the parts that you care about, like loading the Facebook user profile or whatever. There are other bindings, though. Lots of other bindings. If you go to github.com/spring-projects, not Spring Source anymore, /spring-social, /wiki, /API-providers, you'll see this very convenient little table, which you can't see here anyway, listing just a raft of different clients that the community has provided. There's like 30 of them.
So the ones on the previous slide are the officially supported
Yeah.
Spring clients. Those are the bindings that we provide.
Right.
And then there's a number, 20, 30 or more, community supported projects that are built on top of Spring Social.
So for example, when Google Plus came out 2 years ago, I guess, as Craig is fond of telling people, we had a amazing Google binding for Google Plus's API. As soon as that API was announced by Google, within a few days, there was already a working Spring Social Google Plus binding. Because it's OAuth, and we didn't have to do a lot to talk to OAuth. Spring Social does that. All you then have to do is write a class, a client, that speaks the API. It speaks to the domain of Google Plus, Same with Facebook, and Twitter. So these bindings are great. There's Flickr and SoundCloud and Salesforce and Vimeo and whatever. Anything you can imagine wanting to use, there's probably a binding there. In our case, we have this CRM RESTful API that we want to communicate with, okay? So
you didn't mention, though, is that Spring Social actually integrates with Spring Security so that you can build out your own service provider.
Yes. Right. So,
which is actually what?
Well, that's different. Actually, so the Spring Social Security support lets you talk to any of the Spring Social supported bindings and use that as a Spring Security principle. So you can sign in with Facebook or sign in with whatever. Yeah, so that's very, very powerful, yeah. So here, we're writing our own little client, okay? And what I want to do is actually call my CRM API. I've written a class called a CRM template, right? I'm building on Spring Social's abstract OAuth 2 API binding. There's equivalent analog classes for 1.0 and 1.0a. And then I'm just going to go ahead and, in my constructor, I call super. I pass in the access token, which Spring Social will have provided for us. And Spring Social will actually persist that and make it available for me. And in all other code, I can make a request of the service using the REST template that Spring Social gives me. So get REST template dot get for entity, and I'm going to call the URI, and I'm going to expect a list of customer objects back from the response. Okay. Wow. 15 minutes. Good. So yeah, this is very, very powerful. There's a lot of stuff here. It's just REST template. It's very convenient. Do check it out when you have a second. We're going to go ahead and run a quick client here. You have to answer questions, by the way. You have to it's like a form. You answer the form, and Spring Social knows what to do. You tell it, hey, how do you tell if your API is up and running? Answer the question however you want, specific to your service. How do you tell what the user profile information is? Do it specific to your service, etc. And update status. You have to provide a way to update the status. On Facebook, this means post to wall. In Twitter, this means tweet. In our case, it's a no-op because we don't have this notion of posting to the CRM REST API and updating a status. There's no sense of that, right? So, okay, quick example here before we move on very, very quickly. This is a public static void main class. Nothing special. This is actually not how OAuth was envisioned to be worked with, right? It's just, we don't have a web service to which our CRM API can call back to, right? I'm a client, and I want to get an access token, but there's no web service for it to post back the access token to, which is what OAuth expects to happen. So we're going to do a little bit of hackery here. Look, I'm setting myself up as the Android CRM. I'm going to say connect to this API, call this OAuth authorized URI, call this token URI, and then I can actually just interrogate the API itself, right? So I can go, here's my current user, look up a customer, create a customer called Nicolas Cage because he's everywhere. Get my profile photo. This in turn returns the bytes for the photo itself. Maybe even save I'm going to save the bytes to the desktop here, and then query for any customers named Josh, and then blah, blah, blah. So let's run that. Blah, blah, blah. Questions so far? I know we're moving a little quick, but now's the time to ask questions. So first things first, it's asking me. I used Java auth desktop to tell the system to launch my native browser, whatever that is, and use this URI. It's saying, do you authorize Android CRM to mercilessly and endlessly spam your friends, family, and loved ones? And I say, yes, I authorize it. And it says, great. And it redirects back to a URI. I don't care what the URI is. All I need, is this access token parameter that's transmitted along in the request, in the response, I mean. So I say here, grab that. And then, again, this is gnarly. Just hold your vomit until later. I have a swing dialog that pops up where I prompt for the user access token, because Spring Social needs it, right? There's no web, I don't have, it's public static void main. There's no web server here. So I'm going to just copy it and paste it here. So I get that, go back to my code, and you can see that I have all this stuff happening. All this, like I created a request for customer search. I actually I created a, where's Nicolas Cage? Well, whatever. There it is. I actually called the resource to create Nick Cage record and all that stuff. And down here, I got my photo and all that stuff, and I saved it to the desktop. If you go to my desktop here, you can see the profile photo is up and running, right? So I have the photo there as well on my desktop. We are successfully able to work with the service. Now, this is not the be-all, end-all of what you should do with Spring Social by any means, right? So Spring Social provides a great way to do all that stuff. It's a very nice library. My favorite feature of Spring Social, it's in Java. And you know what runs in Java? Android or Dalvik or something, whatever. It happens to work. You take the same code and it works. It's not Java, but it works.
Mostly.
Mostly, yeah. And so that is good enough for me. And then once I have that, I can then go to this poor guy, and he's got this amazing project called Spring Android, which makes it very easy to use the REST template on Android.
So with Spring for Android, we've actually taken the REST template from Spring Core, and we've made it compatible with a number of versions of Android, all the way back to 2.1. And it was a bit of a challenge, because obviously you're dealing with a number of different versions and all the different possibilities of the manufacturers having their own versions of Android as well. And on top of that, what we've done is we've made Spring Social accessible to the Android project, so that you can use Spring Social from within your Android applications. And Craig Walls and I spent a lot of effort to make sure that that would work. So this statistic is from 2010.
That's very old at this point.
More than 500,000 activations every day. Interesting.
As of 2010. Android is by far the most pervasive platform in the world. I think it's now since exceeded Windows installations, not just iOS. I mean, it's long since left iOS in the dust, but Windows. I mean, operating systems that installed, there are more Android than anything. Soon we'll be comparing Android installations to ants, maybe.
All right, sir, where are we?
Yeah. Are we in the right console? Oopsie. Voila.
Aha.
You want to try this one? It's all loaded already, so you don't have to redeploy.
No, that's a different emulator.
Where's the other one, though? The original?
It was too big.
But we might see the music go there.
No, that's.
Oh, you closed it already. Okay, go ahead and let's redeploy. Update that. Update. Go ahead and hit edit first. Edit configuration. Sorry, buddy. We had a small bit of technical difficulty in the beginning in that our emulator took up too much screen space. Error. Okay, hit OK. Yeah, I know, you're unhappy. Anyway, it's like cold medicine. You just have to swallow. Just push through the pain.
Are we building?
Loading. So we're deploying an Android client that we've developed here. It, in turn, builds on top of the OAuth stuff. Can we show the code? Can you show how we wire it up, or just show something? I don't know. We're not going to dissect all the Android code here, but how many of you have built an Android app at some point? Oh, guys, cool. Right on. My kind of people. Android is it's very powerful, right? You have a lot. There's nothing you can't do. You're going to be limited mostly at this point by the quality of the device, right? But in theory, it's as powerful as any operating system you can expect on a phone can be. So it's a very, very nice place to develop apps, and it's certainly a commodity enough that it has reach everywhere, you know? It's actually also becoming the de facto thing in the enterprise because it's so pervasive, right? It's one thing to go to, people in China or in India and say, hey, you should buy this really, really expensive iPhone, but you can get commodity, really, really usable Android devices. And more to the point, India, for example, is now expected to be the #1 enterprise software developer because there's such an entrenched Android development community by 2030, right? It's a very, very powerful thing. There's going to be more people developing Android code than desktop browser-based web apps. Okay.
So what we wanted to show here is how you can actually utilize a web view to authorize with OAuth into an Android client. And that's one of the reasons that we created 2 different clients in the Spring Security configuration.
Tab again, yeah. There's some quirks with the emulator, but this works just fine on the device. I'm not sure why, if I'm honest. Sign in.
So this should look very familiar to you because Josh has showed you on the actual little tool that he built as well.
You broke it. Wait. No.
No.
Redeploy. Oh.
This is what we get for trying to build a really complicated app.
It's not that complicated.
This is a complicated demo.
Yeah, that's true. But it's real life, okay? The point is, this is actually sort of you can now take this to market. We're secure, we actually have a very useful API, it's fast, it's, What? Bear with us, we're going to be running a little long. Just hang tight. What happened?
We're waiting.
Because we had the application loaded before, and then I restarted the server several times, so that's why everything's all afoul. Oh, come on. Really? Did you kill the existing one? Oh, we're running it and that. So we're using Android because Google, in the last Google I/O, announced the Android Developer Studio, which is a fairly, adept environment for building Android applications. They have a free version of it, so it's definitely Google's saying that that's their recommended way to go. It happened to be workable for us, so we used it as well. What's happening in the console? Oh, how many emulators do we have open?
Those aren't emulators.
So sad. Wildcat. Where's the old one? Let's deploy the old one. Terror. Okay, guys, bear with me here. Okay. Goodbye. Oh, oops. Wait, okay, never mind. Ah, bugger. Okay. So, here's the application. No, nobody asked you. Go away. Whatever. Do it later. Now. Okay.
The challenges of the Android emulator.
So, there we are. Take a photo. You would.
Oh.
So sad. Hold on. This app works, I assure you. It's just demo presenter's luck. Can we, you guys want to bear with us? Is that okay? You guys are in a hurry, I imagine, but just hold on tight. Let's see. Hit OK. Deploy one last time. This time for all the marbles. If not, we'll just proceed. As we do have actually an iOS client to show you too, so you know, loaded for bear here, guys.
So, John,
Yes.
question in the meantime?
Yeah. 10. Out, please. Questions. Flood.
So going back to HATEOAS, I don't know how to pronounce that.
The what?
The HATEOAS.
Oh yeah. Sorry. Yeah.
Is the goal of using that to provide as few endpoints as you possibly can, and then documenting that one, you use that to traverse your domain trees. Is that sort of what you're aiming for there?
That's it. It is certainly one effect of that. It is to decouple the client, as you just suggested. I'm rephrasing, from the URI. So yes, ideally, assuming infinite performance, everybody would start at / and then dynamically drill down to the endpoint that they need. Of course, you can't always do. You don't want to have to retraverse 3 different levels of organization just to get back to the photo. Yeah. So clients have the right and the permission to cache the URI. I would argue that HATEOAS is very good in promoting discoverability during development. You know, better understanding of navigation and so on. Open that thing.
So the Android code is all available in the repository that Josh mentioned earlier. And
There we are.
so we also have a fully featured iOS client available as well, and it does a whole OAuth 2 authorization. And it
Tab. Wait for it, guys. It's going to be epic or it's going to be not so. It'll be epic. Either way, it'll be something asterisk pick. Tab, maybe? Yes, okay. So now I can, we can change our photo here. Take a photo. Say smile. Okay. Okay. So that actually goes back to the browser. If I go to here, see. All right. So there's a photo being uploaded to the service. All through OAuth, right? So we're working with that. There's another version, same idea, same possibly awesome thing.
Real quickly, just show you how you can do it on here. So we ran into one actual minor bug with Spring Security in the configuration of the 2 different clients, and we're going to be following up with Rob, as we mentioned earlier, but we actually have to change the configuration slightly to get the image to show up on here.
But we did the other endpoint, which is to load all the customer data.
Yep.
So there you go. That's actually retrieving data. Again, they're both OAuth established sessions. They both work just fine. One is using one type of flow for OAuth. The other one is using a different type altogether. Whew. There was actually a great set of slides that we're going to present to you. That's the best part. You guys missed out totally. No. All that iOS development, we're going to get into core C development. I was hoping you guys brought your C environments, but if you didn't, well, maybe next time.
But the good news is like I said, it's all available in the repository, and it should be fairly self-explanatory how to get up and running.
Right. Okay. Questions?
From a HATEOAS REST perspective, what do you recommend from a situation where you don't want REST services to be chatty? You've got, let's say, holdings in an investment firm, and you've exposed market data through a REST service, and I don't want 50,000 REST calls per investment instrument basis. So the only solution was to post a set and then get them back. And I know it's not HATEOAS, but is there any other way to do that kind of stuff?
So there's some scholastic conversation to be had around HATEOAS, and then there's some real-world examples as well, and sometimes those don't necessarily mesh quite as well. Certainly when you're talking about mobile devices and slower connections and things like that, sometimes you want to populate more of the data and not have to make these traversal calls and explore that API. So I would say that's perfectly valid. I mean, assuming you're doing your testing and trying to reduce the bandwidth and et cetera. So.
Thanks for coming, by the way, guys. Just for those of you who are checking out, thank you so much. Hope to see you guys again.